Welcome back, guys. So in this session, we are continuing about two-port networks. So in this class, we will deal about what is the interconnection of a two-port network. So interconnection of two-port network. So in this interconnection of two-port network, we have three interconnections that are series interconnection, parallel interconnection, and cascade link. Okay? So in series interconnection, what we intend to do is here, when two-port networks, two networks which are connected in series, to represent that in a one form. So like that, if for example, in general we have an impedance, let us say that is Z1 and Z2. So the total impedance can be calculated as total impedance is series of Z1 plus Z2. So when two-port networks are in series, you should be in a position to think that the two-port network of two Z parameters of one network and Z parameters of other network should be series. That means addition of two Z parameters, two-port Z parameters gives you overall Z parameters of them. So for that reason, for example, to explain the series connection of two-port networks, I am taking two networks. Let us say this is network N1 having two ports, and again I am having another network N double dash having another two ports. So I am giving naming for this input current as I1 dash, and input current of second port, two port is other port is I2 dash. Okay, and then I am taking this network as N double dash. I am giving an input current of let us say I1 double dash, and input current of second port is I2 double dash. So to make this thing in series, how we will connect this? That's the issue. Here the connection of these two things will be in such a manner that it should be series. Okay? And one more thing, the input voltage which I am taking for the network N1 is, let us say V1 dash. So I am taking in the suffix dash means one, in one dash means network 1. And I have the output terminal voltage, let us say V2 dash. Okay? And now for this I am taking V1 double dash, and for this we are taking V2 double dash. Okay. Now I want these two ports to be in series. That means the current should flow in one form. So I'll chart these two things. Okay. If I make this connection means this is one that the whole thing should be in thinking that it is in one impedance. The whole thing should be in another impedance. Addition of these two will get a series form. Therefore, the input voltage, the overall input, this is the overall input. This is the overall two-port network. See, this overall two-port network having internal other two-port network which are connected in series. The overall terminal voltage, let us say this is V1, and the overall terminal voltage, let us say this is V2, and the input current as I1, and input current of external terminal is I2. That means the overall input, the overall Z parameters, the input voltage, and in first terminal and second terminal we are taking. Okay. Now let us take the Z parameters of network 1 as Z11 dash and Z12 dash and Z21 dash and Z22 dash. Okay. So the Z parameters of a network 1 can be given as V1 dash equal to Z11 dash I1 plus Z12 dash I2, and V2 dash equal to Z21 dash I1 plus Z22 dash I2 dash. Okay. Now for network 2, so for second network, we have z parameters as v2 dash equal to z11 dash double dash I1 double dash plus z12 double dash I2 double dash and v2 the v1 double dash and v2 double dash equal to z21 double dash I1 dash and z22 double dash I2 double dash. Okay, this is the z parameters of network 1 and this is the z parameters of network 2. So from this circuit we have a few things. So basing upon the equations from that circuit, we derive the overall z parameters. That is what is, if you see carefully, the voltage which is there now here, it is the division of V1 dash plus and V2 double dash. Okay, the whole voltage, say for example, this is a small network, this is R1, R2 and its supply voltage V. So here V equal to what? V1 plus V2. In likewise, V1 is equal to drop over this port and drop over this port. Therefore, we drive V1 equal to V1 dash plus V1 double dash. Okay? And the voltage drop of other two port, second port is, we can write V2 equal to what? V2 dash plus V2 double dash. This is about the voltages here. Coming to the currents, if you see carefully, the current I1 is equal to, the current I1 is equal to I1 dash, again equal to I1 double dash. The same current will used to flow here. And again, current I2, the other port, we have I2 dash equal to I2 double dash. Okay? Now, based upon these equations, we need overall parameters. So, actually, our two-port network gives in general Z parameters is V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. So, here having a V1 and V2. So, we are having again other two-port networks, each individual network. Substitute these equations here. So, substituting, let us say this is equation 1, equation 2, equation 3, equation 4. Substitute equation 1 and equation 3 in, let us say this is 5 and this is 6 in 5. Therefore, we get V1 equal to Z11 I1 dash plus Z12 dash I2 dash plus Z11 double dash plus I1 double dash plus Z12 double dash I2 double dash. Now the main thing is happens here. So as we derive the voltages and we have the currents. So replace this I1 double dash with I1 and I2. So we have I1 dash equal to I1 and I1 double dash equal to I1. Therefore, we make this thing as I1 dash I1 and I11 dash equal to I1 and again this thing as Z12 dash I2 plus Z22 equal to I2 double dash. Okay? Z12 double dash. So we make I1 common, so therefore Z11 I1 plus Z11 I double dash into I1 plus Z12 dash plus Z12 double dash I2. Okay? So this is equation V1. And again now equation V2. Similarly, equation V2 so equation V2 will be written in the form of, so substitute the equation 2 and equation 4 in 6. Now for V2 we have V2 equal to what? V2 dash plus V2 double dash. Substitute the equation 2 and 4 in 6. Therefore, you get V2 equal to, substituting these equations, Z21 dash I1 dash plus Z22 dash I2 dash plus Z21 double dash I1 dash plus Z22 dash I2 double dash. Therefore, solving further we will get in the form of Z21 dash plus Z21 double dash into I1 plus Z22 dash plus Z22 double dash Z22 double dash I2. So this is the final equation of V2. Okay, these are the two equations we obtained. Equation, let us say this is 7 and this is equation 8. So if you carefully observe here, what we concluded here is equation 7 and 8. So join that equation 7 and 8. So the final conclusion is very much important. So Z11, so Z1 and V2, V1 and V2 in the matrix form, if you want to write, we obtain like this. So Z11 plus Z1 dash plus Z11 double dash plus Z12 dash plus Z12 double dash and Z21 dash plus Z21 double dash. Again, Z22 dash plus Z22 double dash. This is I1 and this is I2. So, I said before, the overall parameter of a Z parameter when two parameters are connected in series, they should add the individual Z parameters. So, we are having individual Z parameters of tube network. Therefore, the overall Z parameter can be given as Z11, Z12 equal to Z21, Z22 equal to Z11 dash plus Z1 double dash Z12 dash plus Z12 double dash and Z21 dash plus Z21 double dash and Z22 dash plus Z22 double dash. So you simply, for solving the series Z parameters, when so for example the questions will be in the form of let us say, for example, so let us say for solving Z parameters we need a T circuit. Say they'll ask you to find the two similar T circuits are connected in series, or two other different circuits are connected in series. You will find the Z parameters of this circuit. Let us say this is circuit N1 and other circuit of different value. Let us say N double dash. You will find the Z parameters of these two circuits. After finding the Z parameters, the overall parameters will be in the form of you will find Z11 to Z2, you will get different values and you will add that, and the overall Z parameters of the series connected two-port network will be obtained. This is about series parameter. So finally, we obtained here is the final equation is we are adding individual Z parameters of the network. This is the solution, and the theory is important for you to write the equation. Just simply, you need not to be by heart all these things. Just the main whole heart of this thing is how to represent the currents and voltages by knowing the basics, that is the V1 is equal to voltage drops and V2 equal to voltage drops and same current is to flow. This is about a series two-port network. Now we go to parallel connection. So I am taking the same networks. is taking the same network. Okay, this is the network. So now we should keep in mind that when two impedances or two impedances, let us say when two impedances Z1 and Z2, or sorry, Y1 and Y2 connected in parallel, so overall impedance is Y1 plus Y2. So this is also big. This Y1 is one two-port network and Y2 is another two-port network, and we need to do in parallel. How we connect in parallel? To justify the parallel connection, we need to connect the two-port network like this, zigzag manner. Okay. Now I give the namings of the two-port network. So this is the current. Let us say for this current, this is first to this port. I name current I1 dash is flowing, and this I2 dash is flowing. And now for this network, I1 double dash is flowing, and for this input network, I2 double dash is flowing. Okay, and the currents which is given as V1 double dash, and for this is V1 dash, and again for this is V1 double dash. So V1 dash, V2 dash, and V2 double dash. One thing, guys, when you are familiar with the basics, you are the bosses of the circuits. So you can do in any manner. So, but you need to follow the fundamental things carefully. Okay. Now the input current voltage. Let us take this is the overall. This is the overall network. So these two port networks are connected in parallel, and this is the overall network. That is the overall. For this overall T network, let us say Y1. So this is I1, I2, V1, V2. So we will find for that Y network. Okay. Let us say this is input current. I1 is flowing, and for this I2 is flowing for the overall network. This is the overall network. In this box we are having the parallel connection, and V1 is flowing input, and again V2 is flowing output terminal. Now our thing is the basic elements. Let us say how the currents are flowing and the voltages are there, we have to observe. If you see carefully, the voltage 1 is there. It is equivalent to input voltage of network 1 and equal to input voltage of network 2. Therefore, we have the equation V1 equal to V1 dash equal to V1 double dash, and V2 equal to, so same voltage drop will be there at two port networks. V2 equal to V2 dash equal to V2 double dash. Now we observe the currents, how the currents are flowing. So currents I1 will be, see here at this node, the I1 current is getting division, that is I1 dash and I1 double dash. Therefore I1 equal to I1 dash plus I1 double dash, and I2 equal to this output terminal current, I2 is flowing, is again divided. Therefore I2 dash equal to I2 dash plus I2 double dash. So simply the similar fashion which you have done in series, what happened is admittance parameters or short circuit parameters of two networks which are connected in parallel, we add them. The overall parameters, that is overall parameters, we will have that y network dash plus y double dash. Okay, this is the impedance of admittance matrix of input one port network and admittance matrix of second port network. We will find that how. So here for network N1, we have the admittance parameters. Let us say I1 equal to y11 dash y11 dash V1 plus y12 dash V2, and again I2 dash equal to I21 dash V1 plus y22 dash V2. This is the admittance parameters of network 1, and for the network 2, the admittance parameters you have as let us say I1 double dash equal to I11 double dash plus V1. So again V1 dash, V1 dash, V1 dash, V1 double dash plus Y12 double dash equal to Y2 double dash, V2 double dash, and Y22 double dash equal to Y21 double dash, V1 double dash plus Y22 double dash, V2 double dash. Now what we need is, we need for getting overall Y parameters, we need I1 in the form of I1 and I2. So we have I1 and I2, and we have each individual I1 dash and I1 dash. So let us say this is equation 1, this is equation 2, this is equation 3, this is equation 4, and this is 5, and this is 6. So substituting equation 1 and 2 in 5. So we get y1 equal to, substitute this equation, y1 dash v1 dash plus y2 dash v2 dash plus y11 dash v1 dash plus y12 dash y double dash v2 double dash. Okay, and from after getting this, we have v1 equal to v1 dash and v1 double dash. Substitute v1 dash v1 double dash here with v1. Therefore, after simplification, you get v1 double dash plus v1 double dash into v1 plus v12 dash plus v12 double dash into v2. This is one equation, that is I1 equation you got. And again, substitute equation 2 and 4 in equation 6. You will be getting I2 equal to y21, substitute y21 dash v1 dash plus y22 dash v1 dash plus equation 4 in equation 6. So y21 double dash v1 double dash plus y22 double dash v2 double dash. Now here our job is to substitute v1 dash with v1 and v2 dash and v2 dash with v2 dash and v2 double dash with v2. Therefore we get, after solving, v1 dash plus v21 double dash into v1 plus y22 dash plus y22 double dash into v2. This is equation I2. So this equation and this equation, let us say this is 7 and this is 8. So comparing these equations 7 and 8 with overall y parameters, the overall y parameters we have, let us take this I1 and I2, the overall y parameters, you have y11, y12 and y21 and y22 equal to v1 and v2. So equation comparing these two I1 and comparing these two I2, you got the overall parameter y11 equal to sum of the impedance of these two parameters. That is, the conclusion part is the y11, y12 and y21, y22 will be equal to, the overall y parameters will be equal to individual addition of individual y parameters, that is y1 dash plus y1 double dash and y2 dash plus y12 double dash and y21 dash plus y22 double dash, y21 double dash and y22, so y22 dash plus y22 double dash. That's it. This is the overall, that is by this equation, that is equation 7 and 8 compared with equation these matrices, you will be getting overall this thing. The overall, these equation indicates that the overall y parameters is the addition of individual y parameters. Okay. So in this y parameters, the questions will be asked in the form of let us say so for finding the Z parameters, what do? You convert every circuit into a T circuit. Okay. Now to find the Y parameters, whatever the circuit which is given to you, you convert them into pi circuit. Okay. Now if a question asked like this for you, like so for example, if one circuit, this is network 1 and this is network 2. Okay. So these two networks are connected in parallel. Find the overall Z parameters, Y parameters, the overall Y parameters. So what you do is you just convert this star to delta and convert this as pi, and you will get Y parameters of this circuit, and you get Y parameters of this circuit. After getting the Y parameters of this circuit and Y parameters of this circuit, the overall parameters of these two circuits will be addition of their individual parameters. Okay, so they may be give two equal circuits of T circuit. If they give T circuit for finding Y parameters, you need to convert them into pi circuit. If they give pi circuit, it is not an issue. You will be connecting finding that. So we will solve on 2 or 3 problems.